We are continuing ordinary differential equation, in which we see earlier the definition of ordinary differential equation, the order and degree of differential equation, and nextly we discuss about so many methods of solving differential equation. First one is separation of variables, the second one is homogeneous equation, and in comes the upcoming part is exact differential equation. In order to proceed further, we have to define first of all partial differentiation of any function. Let us consider the function y equals to say fxy. The function of two variables, say fxy. So in which we have to observe that part. Now the partial differentiation means, let us consider the function u equals to fxy. If we consider the differentiation of the function u with respect to x treating y as constant is usually denoted by the symbol del u del x, or u suffix x, or f suffix x, or f del f del x. So is denoted by the partial differentiation of the function u or f with respect to x treating y as constant. Similarly, if anyone can consider the partial differentiation of the function u with respect to y treating x as constant is usually denoted by these symbols. These are different from the total differentiation. Actually total differentiation of u is with respect to x is denoted by du dx actually. Now in comes the upcoming factor is partial differentiation. Partial differentiation is actually the differentiation of the function partially with respect to x treating y as constant. So in what way we have to proceed? So take one example which is in our right hand side, say problem first. This is the problem 1 we have choose, that is 2x cube plus 4y dx plus 4x plus y minus 1 into dy equals to 0. Let us verify this equation with the common equation of differential form, that is m dx plus m dy equals to 0. Let us consider this equation, try to verify with this equation so that we get m as, what about m? M is obviously 2x cube plus 4y, and n which is obviously 4x plus y minus 1. If we compare this equation to this equation, we get this. Then find del m del x, del m del y, and we have to find del n del x. So what is an exact differential equation? Why we have to find this part? Why we have to find this part? So first of all, we have to define the exact differential equation. What is that? The differential equation of the form m dx plus m dy equals to 0. The differential equation of the form where both m and n are the functions of x and y is said to be an exact differential equation if these two are equal. That is, if del m del y, if del m del y equals to del n del x holds. If this holds, we show that this equation is an exact differential equation. Then the procedure comes, that is how we have to proceed for solving through exact differential equation. That is another fact. Now try to find del m del y, taking the differentiation of m partially with respect to y treating x as constant. So x as constant, this became 0, and 4 into differentiation of y with respect to y, which is 1, so this is simply 4. And obviously here del n del x gives the partial differentiation of the function n with respect to x treating y as constant, that is this term is 0. Here first of all with respect to x, for constant x derivative of x is 1, y as constant derivative of this is 0 minus 0, so we get it as simply 4. So we observe here that therefore both the partial differentiation del m del y equals to del n del x, we see that this equals to this. Then what happens? So the given equation, so conclusion is that the given equation is an exact differential equation, solution is another way. Exact differential equation, solution is what? Solution is integrate m all in your PDF also, integrate m with respect to x, treating y as constant, plus integrate n with respect to y, not only that, in which the term x is absent, not only so আরো কিছু আছে absent, and then equate to a constant, equate to a constant. So what is that? Equate to a constant. This is the solution method. This is the theory of solution of exact differential equation. So what is that? First, integrate n with respect to x. What about n? This is n. 2x cubed plus 4y dx plus integrate n. What about n? 4x plus y minus 1 whole dy. But there is a restriction. What is that? Integrate n with respect to y, it is here, in which the term x is absent. So where x is absent should be deleted. So here 4x should be deleted. So it can be written in this way, y minus 1 dy, and then equate to a constant. What about c? C is the integrating constant. Obviously. Then, so what happens then? So 2 which is constant here, obviously x cube dx plus 4y which is constant, both are constant, can be taken outside the sign of integration, plus integral of y dy minus whole dy, that equals to c. And what we get? 2 into x to the power 4 by 4 plus 4y constant, this is obviously x plus y square by 2 minus y equals to c. So if we simplify further, we get it as, therefore 2x to the power 4. Here it can be proceeding this way, 2 into this cancels here, and finally x to the power 4 plus 8xy plus y square minus 2y, that equals to twice c. So it is nothing but k should be replaced here, where k is twice c, which is another constant, which is another আরো একটা আলাদা constant হিসেবে choose করা হয়েছে which is another constant. So that ends the problem. So which is the result, which gives the result x to the power 4 plus 8xy plus y square minus twice y equals to k finally.